All right, it's noon. Let's rock and roll. Thanks everyone for joining us today for another webinar through our Stender School at the College of St. Scholastica. I'm Joe. I'm an admissions counselor for the Stender School. I always just like to remind folks that fall is approaching quickly. Fall is always approaching quickly in my universe. What I'm going to do as the presentation starts here, I'm just going to put a link to some of the programs offered through our college in the chat, and I'll put my info in there as well. Today we're talking about data visualization with Tableau. This is some content that is covered in our data analytics masters as well as the CERT. Dr. Brandon Olson will be the presenter. He is an instructor and the program director for our data analytics program. So if you want to check it out, please share it. Please take a look. If you or anyone that you know are interested in the data analytics program or any of our Stender School programs, we're happy to meet with you at a later time. Zoom, phone call, in person, whatever works for you. Also, just to note that we will record this, and if you want a copy of it later, I'll be sending a follow-up. We'll include that, and if you want the slides as well, we can get that over to you. But with that, I will turn it over to Brandon.
All right, thank you, Joe. All right. So just as a reminder, this College St. Scholastica, we've been around since 1912, and we have, you can see here, our Benedictine values: community, hospitality, respect, stewardship, and love and learning. And as Joe mentioned, he's our admissions representative, and here's his contact information as well. And I should have been using these slides along the way. Sorry, Joe. And here's myself. I'm a professor of data analytics, IT, and project management, and I'm the director of our graduate CIS or graduate programs in the CIS department, and those are the applied data analytics and project management programs. All right, so today's presentation is on data visualization with Tableau. So what I'm going to do is I'm going to cover the different types of analytics to kind of give you a little bit of background, talk about the purpose and definition of data visualization. We're going to take a look at the data that we're going to use in this presentation, and then I'll introduce you to Tableau as a visualization tool. And then we're going to tread on some dangerous territory of doing a live demo, and those always go poorly, but I have some notes here to make sure that I don't forget anything. So if I'm looking down, I just want to make sure that I'm following all the steps that I wanted to take. So I'm going to be spending most of the time here doing a live demo of Tableau on this data set that I'm bringing in, so that we can see how Tableau actually works and kind of the thought process that you would follow in doing visualizations with Tableau. So let's go to the next slide here. And this is the different forms of analytics. So there's 4 different forms of data analytics. There's descriptive, diagnostic, predictive, and prescriptive analytics. And you can see here on this graphic, they range in complexity. You can see from the left to the right, higher complexity, but the higher complexity also provides greater value or better, increasingly more complex or valuable insight. So descriptive analytics, that's going to answer the question of what happened. So we're looking at historical data to understand what happened. And then if we want to step that up, we can ask questions that at the diagnostic level to understand why things happened. And then at the predictive level, that's looking at what's going to happen in the future. So using past data, we can build models to predict what will happen in the future. And then the final kind of the optimal step is prescriptive analytics, and that's building models to determine what should we do. And those are quite complex models. So what we're going to be doing today is some descriptive, mostly diagnostic analytics, with a kind of dipping our toes into just a little bit of the predictive analytics. So that's kind of the domain areas of analytics that we're going to be covering today. All right, so first of all, the definition of data visualization, I found there's a lot of different definitions. I thought this one is pretty good, so I captured this one. So data visualization, it's the practice of translating information into a visual context, such as a map or graph, to make data easier for the human brain to understand and pull insights from. It's the term is, but the term is also interchangeably with other terms such as information graphics, information visualization, and statistical graphics. So it's really providing some type of visual representation of the data. So the main purpose is really to make it easier to see some trends, patterns given the data. So we can take data and make it visual to be able to see these patterns and trends that we wouldn't see just by looking at the data. So really we're taking data, putting that together to form information, and then providing this visualization so that we can capture knowledge or new insight from the data, and then be able to apply that to generate the wisdom that we are going to be able to obtain value from. So it's really converting data all the way up to wisdom using visualization and data analytics. All right, so the data that we have. Excuse me. So this is our data, and what we can see here is this is going to be data from the County Health Rankings organization. Every year they put out healthcare related data that's reported out by at the county level. So for each county, there's information, healthcare related information for each of these counties. We have, they can see right here, these are and this is an extract and some filtering that we did. So we did some data wrangling here to take that raw data and to just pick out the rows and columns that we want to be able to use, do some data cleaning. And this is what we have remaining. So we have a set of a little over a dozen rows or dozen columns that we're going to be looking at in this data set. And we're just going to select a couple of these in this analysis. But this data wrangling is not an easy step. In data analytics, that's probably about 80% of your work is actually getting the data to be in a format that's usable. But for this presentation, that ugly work is done for us already. And now we get to do the fun part of just the analytics. So here, what you can see here is the Tableau environment. So Tableau is, today I'm going to be demonstrating the desktop version of Tableau. Now, what I want you to know, though, is if you don't have access to Tableau, take a look at Tableau Public. What you can do is you can create an account, online account, where you can use a lot of the functionality that you're going to see today exists in their free Tableau account. So what you can do is go to Tableau Public or find the Tableau Public website, create an account and do these same type of visualizations in that. The only caveat is that is public information, so that you whatever you put together, that those plots that you create can be seen by others as well. But it's a good way to practice. If it's proprietary for your own organization, don't do that. But if it is something that you're just wanting to practice, take a look at Tableau Public. Again, what I'm looking at today is the desktop version. So this will be stored only on my desktop and not out on the websites. So what I'm going to be doing is pulling data in. Tableau can take data from a database or from different flat files, text files, Excel files, JSON files. What I'm going to be using today is an Excel file. I'm going to bring that into Tableau, and then from Tableau, I can take that data and generate different forms of visualizations, like you see off here to the right. All right, and so what I'm going to do through this demonstration that we're going to go to next, first I'm going to create some calculated fields. Then I'm going to look at the data geographically, and then I'm going to create some scatter plots, do some groupings, do a little bit of linear regression, and then do some formatting to make sure that the data is presentable. And I think that's an important part of this visualization. It's not just a matter of creating the plots, but also making sure that the plots are going to be digestible. So when you're doing data analytics, you always have to remember what the purpose of the analytics is going to be and the visualization is going to be, so that you're making sure that you communicate the right message as part of your visualization. All right, so with that, I'm going to just tab over here to my Tableau instance. So here's when you open up Tableau desktop, this is what it looks like. What I'm going to do is I'm going to connect to a file. In this case, it's an Excel file. So click on Excel. And then I get a pop-up window saying, let's find your Excel file. And I have it in my default directory. So I'm just going to select the Excel file and click on open. So that now connects Tableau to that Excel file. And what I see here is the fields that it found in that Excel file. That's right here. And then it also shows me the first several rows of data in that Excel file. So you can see the data, what the data looks like. And this is an important step because it's really helpful to understand kind of the state of the data or the format of the data as well. So I can scroll through here and see that I have some text fields. Percent uninsured, that's as a decimal percentage, not a formatted percentage. That's important to know. So each one of those percentages are in terms of a decimal percentage. So I will have to keep that in mind as I'm working with this data. And there are some null values. So no value here, null value here. That means we don't have a value. And scrolling back, I can see, so at the data is intended to be one row for each county across the United States, but there's also rows for states and the United States. But we'll see, though, is the states in the United States all have trailing zeros. So every county is going to end in a numeric value, whereas the state level in the United States all have 3 zeros at the end of their value. So that's something important that we're going to have to keep in mind as we build some filters in the data. And so I can scroll all the way across and see the different fields that I have to understand what I'm going to be working with. But one thing to note here, though, so I was seeing decimal percentages for some of these, but now when I get to the percent with high cholesterol or taking blood pressure medicine, those are written as a percent without the percent symbol. So we might have to work with some formatting along the way. So that's the reason why you're going to take a look at your data before you start working with it. You have to understand the data that you're working with and the format that it's in. So I can see that I might have to do some manipulation with the data to get it in the proper format for my visualizations. All right, so what I'm going to do is I'm going to go through a series of a couple different plots, do some formatting. I'll try to end about 10 minutes too. So if we have questions, we can get to those as well. So we'll see how far I can get into this demonstration then. All right, so with my data loaded, now what I'm going to do is I'm going to start with my first visualization. So I'm just going to click on this sheet 1. And now we're at the staging area for our analytics. A second, let me move this Zoom window down here. All right. So first step, what I'm going to do is I want to create some calculated fields. So all my data is over here. But one of the nice things about Tableau is you can take your existing data and create new data with this. So what I'm going to do, just for the fun of it, so the percent stroke, that's what we're going to focus on today. Let's say that's going to give us the percent of the population that have been diagnosed with a stroke. Let's say I want the raw number. So I'm going to approximate that by taking the population size and multiplying it times the percent of the population that has been diagnosed with a stroke to get a numeric of the number of people in that county that have been diagnosed with a stroke. So this, again, approximation because of rounding and things like that. So I'm going to create a new field. So under analysis, I'm going to select create calculated field. So click on that. And the field name is going to be stroke instances. And that's going to be a calculation. That's going to be the population size. So as I type it in, it goes, it's smart. It's going through my data and different functions to figure out what I'm trying to say. So you can see the hashtag population size. So that's a field. So I'm going to select that. And you can see it puts square brackets around it to recognize that it's a field. And then what I want to do is I'm going to multiply that by the stroke percentage. So that is percent stroke field. So I'm going to start typing in percent stroke and it recognizes it. So I'll select that. But what that's going to do is that is going to give me multiple decimal places. And let's say I want to round this off to, because what I'm looking for is not, I'm not expecting to see number of instances being a decimal place. It really should be a whole number. So what I'm going to do is I'm going to go back to the beginning here. I'm going to use the round function, and then in parentheses, I'm going to keep these two, the two values, and then hit a comma and a 0. So I want to round this off to 0 decimal places. And you can see after I plug that in, Tableau is already looking at it and validating my equation here, and it says that it's valid. So what I typed in here, this rounding the population size times the percent stroke and rounding that off to 0 decimal places, it recognizes this as a valid function and a valid equation. So I can go ahead and apply it, and I can see it created this new field down here. And I click on OK to close that. So now what I did is I just created a new calculated field that is going to represent the number of strokes in a given county. So let's take a look at the data now. So if I click on data source and scroll all the way over, I can see off to the right here the new field that and you can see that it's a calculation field and the number of stroke instances. And we're going to see that these are whole numbers. We don't have any decimal places. Now, for some reason, Tableau by default puts 2 as decimal places, but we can do some formatting as we go to address that. All right, so going to go back to my data sheet now. And there's going to be one more field that I want to calculate right now. And I want to come up with a location field. So right now I have for each county record, go back to my data source here, for each, second here. So for each county record, what I can see here is I have both the state and the county. What I want to do is I want to come up with a field that's called location that's going to combine county with state. So it'd be county name, comma, state abbreviation. So I'm going to go back to my sheet and I'm going to, this time there's another way. So the first time I created a calculated field, I went to analysis, create calculated field. I can also do that by this drop-down box here and then select calculated field from there. All right, so for this time, what we're going to do is we're going to create a calculated field called location. And location is going to be a text field now. So first field that we created was a numeric value. This now is going to be a text value. And it's going to take the county, my county field, see right there. And we're going to add to that a comma and a space, and then insert the state value. Select state. So county, comma, space, state. And so I'm concatenating all those two fields together with a comma and a space in between. And Tableau is telling me that that equation right there for a new text value, that's valid. Let's go ahead and apply that. And you can see I have a new location field. Let's go ahead and close it and then go back to my sheet. Actually, we go back to my data source and scroll all the way to the right. And now I can see my new location, which is the county name and state. All right, so far, so good. So I think what I should do before I go any further, let's go ahead and save this because it's always a good idea to save it. And we'll just call this demonstration. All right, so the other thing is, let's see, what do I want to do next? We're going to name this tab here. So if I double click on sheet name, I'm going to call these states. So that's what I'm going to look at is strokes across these different states. So hit enter and it renamed my tab there. So what I'm going to do first here is I'm going to drag the state over to my work area because I want to create a visualization that's based on my the values for each state. So I click on under the county state. I'm going to grab just the state field. I'm going to drag that over to my main workplace. And when I drop it here, what's really cool is Tableau understands that this is actually before I do that, see that it that has a symbol there, that globe symbol. So it recognizes that this is a geographic field. Whereas all these pound signs indicate that these are numeric values. So what I'm going to do is, again, drag the state field over to my work area, drop that, and Tableau now creates a map. So because it knows that this was geographic data, it's going to kind of intuitively know that I want to look at this from a map perspective, which is what I want to do. So what I want to do, though, is I want to take a look at stroke instances. So the number of strokes by state, so that I can compare which states have more strokes than others. So I'm going to take that stroke instances. I'm going to take that and then drag that on color. So I take, excuse me, drag stroke instances all the way up to my color box here. And that's going to do the shading based on the value. So click release that. And now what it did is it shaded all these based on the number of stroke instances within that state. So what it's doing, it's summarizing, taking all of the county records for a given state, adding them together, and it's providing me the total number of strokes in that state. Before we look at this, there's one thing I don't like, that these are kind of a green and blue. I like it to be different shades of the same color. So if I click on color, I'm going to go ahead and edit my colors. And going from this automatic, I typically end up going with blue to show different contrasts. So if I click on OK, now it recolors my map, and it's all different shades of blue, where the darker shades of blue have higher values. The lighter the shade, the lower the value, the darker the shade, the higher the value. So if I put my cursor over any one of these states, it's going to show me the state abbreviation and the total number of strokes in that state. So we can see that, for instance, let's say Nevada has 9.9 million strokes, whereas California has 109.7 million strokes. So you can see California definitely has a lot more, and that's why it's a darker shade of blue. All right, so but this number of strokes, so it's clearly obvious that California, Texas, Florida, possibly New York as well, these larger populated states are going to have more strokes. So this is not really a good measure to be able to compare different states, to look at the different strokes in each of the states. So that's why we really want to go back to the stroke rate. So this would be the percent of the population that has been diagnosed with strokes. So this would be actually a better measure than our number of strokes. So what I'm going to do is I'm going to take the color piece off. So their stroke instances, I'm going to click on that down arrow, and then I'm going to go ahead and remove it. So we're going to remove that. Now we're left with just the map. And I'm going to now drag over that percent stroke into my color. And unfortunately, I've changed the color again. So I'm going to go back to blue, click on OK. Now it's different shades of blue. But one problem is, by default, it's wanting to sum all the values. So I have a stroke percent for each of the counties within the state. So right now, Tableau is summarizing all those together, and I have this one says 114% of the population has had a stroke. Clearly there's something wrong with that, and that's because it's summarizing the value. What I want to get is the median value, so the median stroke rate for all counties within that state. So what I can do is click on the down arrow there, and the measure. So rather than sum, which was the default, I'm going to change that to median. I want to look at the median stroke rate for all counties across the state. Now, when I put my cursor over, that's a much better value. So that's much more reasonable. That's what I'm looking at. So then what I want to do is I note when I put my cursor over there, you see this median percent stroke. It just provides a 3.6. That really that's not telling us what the units of measure are. So let's change that. So let's go to our tooltip. So what you see displayed there, the state and median stroke percent, that's our tooltip. So what I can do is I can actually edit that. I click on tooltip, and right here is my median percent stroke. I'm going to put there at the end, I'm just going to add a simple percent sign. and click on OK. And now when I put my cursor over there, I've got a percent sign. But it's given me a lot of decimal places, and I really don't think that's necessary. All the data is reporting it at a single decimal place. So I'm going to be using this stroke rate at different points of my analysis. So what I want to do is I want to go back to my data set and change the number format. So if I go over to here to stroke percent and click on the down arrow, I can go to the default properties and I can change the number format. So I click on that. And what I want to do is still a number, but I want to change it to, rather than standard number, I'm going to say a customized number where I can tell Tableau how many decimal places I want. So I just want one decimal place because that's really what it's measured at, is a single decimal place. So those extraneous zeros, it's kind of indicating that's a higher precision than it actually is. It's really down to just one decimal place. So I'm going to change that to 1, click on OK. And now when I put my cursor over it, now I'm just at one decimal place. So the median stroke for Alaska is 3.6%. For California, it's 3.1. For Minnesota, it's 3.7. So now I can see a better value. So that for the stroke percent is now labeled as a percentage, and I've removed all those extraneous zeros that are giving it the illusion of a higher precision than it actually is. All right, so, and again, the darker color represents the higher stroke rates. So down in Mississippi, they're at 5.2, whereas in Utah, they're at 3.2. So we can see the shading tells a story here. So this is a nice slick way to look at stroke rates across the United States. So rather than having 50 different values on a table, even if that's sorted, we can get a good visualization of maybe even regions of the country that have higher stroke rates, let alone we can compare states just visually saying which has a higher stroke rate. So this geographic representation of the data is quite useful if you have geographic data. Since all of our data was reported at the state level, actually at the county level, this allows us to do that. All right, so next what I want to do is take a look at the county level. So let's take a look at a different way to look at the data. I'm looking at the stroke rates at the county level. So I'm going to create a new worksheet. So down here, I'm going to click on this plus sign that indicates new worksheet. And what I'm going to do is I'm going to immediately double click on that, and I'm going to call this tab counties. So now we're working on a new visualization. We can always go back to our initial visualization, but now we're creating a new one. So what we're going to do here is we're going to display the stroke rate for each location. So again, remember that location is a calculated field of county and state. So for each county-state combination, we're going to look at the stroke rate. So what we're going to do is we're going to drag the location. So this is our calculated field of county, state, and we're going to drag that to our columns and drop it there. Next, what we're going to do is we're going to grab our percent stroke and bring that to the rows. And what that did is it created one column for every county state location, and it measured the stroke percentage. So just with 2 drags, I've created a nice bar chart. But it's actually a pretty ugly bar chart because we have so many columns. It's not a really good way to display this. So what I'm going to do is I'm going to invert this. Up here, this is a swap rows and columns. So I'm going to put the percent stroke in the columns and the locations in the rows instead. Now I could drag those and move that, kind of swap these, but there's a swap button that I just click on here, and it's going to make that swap for us. And now it's showing for each row, it's showing the percent stroke. But if I put my cursor over here, it's going to it is again looking at the sum. And I don't want the sum. I don't want the sum of the strokes. I want the median value. So I'm going to change that to median. Now I have the median percent stroke for each of the counties. All right, so what I want to do though is I also want to be able to note here that this median stroke, median percent stroke is actually a percentage. So I want to go back to my tooltip and I'm going to add a percent sign back to there again. Click on OK, and then I can see now we've added that percent. And I didn't have anything to do. I didn't have to do anything with the decimal places because we went back to our data source and changed the data source there, not within the visualization, but actually within the data that we're working at. Now, one thing to note here is we have some null values, and they're all at the state level. So remember, we noticed when looking at our data that we did have rows for one for the United States and then another one for each of the states. And we also noticed that, or at least I told you, that they all had ended in 3 zeros. So now what we're going to do is we're going to filter this data out so that we're not including United States level and state level. So we're just going to have only county level data in our visualization. So what I want to do is I want to use that FIPS value. I'm going to drag that over to our filter. Whoops, held that too long. There we go. Drag that over to our filter. And now what it's going to allow me to do is determine what values I want to filter out, and it shows me all the values right now. So what I want to do is I'm going to use a wildcard filter. And what I want to do is I want to identify those rows that I want to exclude, not the ones that I want to include, but those that I want to exclude. And those have a 0, 0, 0 at the end of the value. So the final three values, final three numbers are 0, 0, 0. So we're going to look for everything that ends with 0, 0, 0 and exclude that from the data set. Now, if we click on OK and take a look at right here, we will see I'm going to hit apply first. And now we can see that those values were removed. Click on OK. So now what we do is, now what we have here is only our counties. And we can see some of these counties are cut off. So what I'm going to just do is get my cursor in between there to get the double arrow right there and drag it to the right, give myself a little bit more space for those counties. Okay, so now what we've filtered our results so that we're only looking at counties. We're not looking at the states or the United States level. Another thing is it's going to be more meaningful because when we're looking at this county level data, we probably are going to be asking ourselves, well, which counties have higher stroke rates than others? So what we're going to do is we're going to then sort these. We're going to do a descending sort. So we're going to the county with the highest rate of strokes is going to appear at the top, and the county with the lowest rate of strokes is going to appear at the bottom. And all that is just touching a button here, and that's going to be a descending sort. So click on descending sort, and it automatically sorted this in descending order. So now we can see here, Greene County, Alabama has this highest stroke rate, and all the way at the bottom, we have some that didn't report, some counties in New Jersey that did not report strokes. But of those that have reported, Arlington County, Virginia has the lowest stroke rate. So now they're all in order. So now this provides more information so we can look at in descending order because we're probably most interested in those counties that have a higher stroke rate. So now we have them identified and in order here too. All right, so next what we want to do is we want to be able to look at this, and rather than having to put our cursor over to see what that stroke rate is, we can actually apply a label to that. So what I can do is I can drag that percent stroke rate. I'm going to use that as my label. So I'm going to drag that over to label, and now what it did is it put that as a label for each horizontal bar. I have the stroke rate, but just like what we were seeing before, is that it's not it doesn't include the percentage sign. And also another thing is it's using a sum. So I want to change that from sum to median, and then for my label, I want to change this to include a percent sign. So if I click on label and then go ahead and change that text, I'm going to click on this ellipse. When I click that up, it brings up the label for that. And then I can simply just add that percentage sign and click on OK. And I can also indicate it's okay to overlap labels, because what was happening, some of these values, they were so close together, given my font size, which I could change, so it's not displaying them. If I click on allow labels to overlap with other marks, now it will insert all those missing values. All right, so now I have all the counties sorted in order of decreasing order, descending order of stroke rates. Looking at this, I can also see, just visually see what the rates are without having to hover over each one. And so the other thing is with each bar, I can see the label is formatted so that I can see the county location and its stroke rate. All right, so that's looking at the county level. So now let's take a look at some potential relationships. So now we're interested saying, okay, now we see which counties have a higher stroke rate. Well, let's try to figure out, well, what's causing this. So I'm going to double click, or excuse me, click on new worksheet, double click on that, and I'm going to call this uninsured. So we're going to look at uninsured rates. So if I click on the percent stroke, I'm going to put that as my columns, and then uninsured as my rows. And now what I see though is I just get one value, right? So there's a couple issues. I just get one value, and there's a missing step. But before I do that, also note that it's going to the sum again. So this percentage is way out of line here, a very high percentage, 400%. So I need to go back and change that from sum to median for each of these percentages, the uninsured rate and my stroke rate. Now I'm getting better percentages, but I can see that it's also as a decimal percent for each one of those. I know I'm going to have to address that. All right, so then what's missing here is I'm just getting one value because it's taken of all the counties, it's taken the median value of all counties for the median stroke rate and the median percent uninsured rate for all counties. But what I want to do is I want to look at this, have one dot here for each county. So what's missing is the details. So if I take that location and drag it to details, now I have one dot for every location value. But it's using these circular dots, and I find those a little distracting. So let's say I don't like the circle dots. Let's say I want those filled in. If I click on shape, I can change that shape to a filled in circle, or I could change it to a diamond or whatever shape I want. All right, so now here's my scatter plot where it shows me all values for all of the county locations and shows me both the stroke rate and the percent uninsured rate. But what it's doing, there's a lot of nulls out there. And I know there's a handful of nulls that were from New Jersey, but it's also including the 51 nulls from each state and then the United States, because those are included in my values. So I want to filter those out. So I'm going to grab my Phipps county or my Phipps field and bring that over to filter. And then again, wildcard, I want to exclude those that end with 000, that they end with that. Now I click on OK, and it's going from 72 down to 21 nulls. So it's removed those 51 values that I was expecting it to remove. So it's removed all the state and the United States level values. All right, so now what I can do is I can take a look at this, and before I do any formatting or look any further at it, I just want to evaluate, is this something that I want to, is this something that's going to be important? And looking at this, I can see that really there's not a strong correlation between median percent stroke and the median percent uninsured. So there might be a slight relationship. You can see that there is somewhat of a trend where the people that have a higher stroke, or the counties that have a higher stroke rate are also the same counties that have a higher uninsured rate, but it's very very weak relationship. See it just by the width of this scatter. So it's really nothing I'm going to pursue any further. So I want to take a look at a different variable. So let's take a look at see if rather than looking at an uninsured influence on stroke percentage, let's take a look at high blood pressure stroke on high blood pressure rates, see if that influences the stroke rate for a given county. So, but what I want to do is I want to use the same format of a plot, but just with a different value. But I don't want to get rid of this plot. So I'm not going to revise this plot. What I'm going to do is I'm going to duplicate it, right click on uninsured, duplicate, create a new tab, double click, and I'm just going to call this pressure. So this will be my high blood pressure. All right, so now what I can do is I've got a duplicate tab now, and I'm going to modify this duplicate. And I'm going to remove, we're going to remove our percent uninsured, remove that, and we're going to drag up there our high blood pressure right there. Drag that up to there. And again, I don't like the sum. I know I have to immediately change that to median. Now we can see that this is a much better relationship, that we have a much tighter scatter here between the stroke rate and the high blood pressure rate for each across the counties. So the definitely looks like a much tighter fit, and this looks like a much better relationship to evaluate. So so now that we see that this is something we want to be able to produce or be able to share with people to gain some insights in this, we're going to do some additional work on this. Because what we might suspect is we saw in maybe more rural areas could have different stroke rates. So what we want to do is we want to not only see stroke versus high blood pressure, but does that relationship look differently based on the rurality of a county? So some counties the population is going to be more urban, and some counties are going to have a population that's going to be more rural. So what we want to do is be able to kind of categorize our results so that they can be displayed by category on our plots. So I'm going to go back, starting with the counties tab here, and I'm going to apply a categorization. So we're going to do this by creating a new field. We're going to create a new field here, and we're going to call this population type. And population type is, we're going to use the RUC codes. The RUC codes are in our data, RUCC, and that's the rural urban continuum codes. And that's going to have a whole number between 1 and 9 that's going to indicate kind of a spectrum from highly dense urban to lower dense rural areas. And we're going to use this function called case. So case, and we're going to be using the RUCC value. So we're going to evaluate the RUCC value. And again, it's between 1 and 9. So when that value is 1, then we're going to assign a field. This population type is going to have a value of metro. And same thing for 1, 2, and 3. So I'm going to continue this on for 1, 2. So 2 is also going to have a value of metro. And excuse me, when it's 3, then it's also going to be metro. Now, when we see a value of 4, we're going to assign it, it's going to be a micropolitan area. So this is going to be the outlying suburb, so to speak, of a metropolitan area. And that's also true for 5 and 6. Excuse me while I finish typing here, 5 and 6. And that's also going to be a micro. And then 7, 8, and 9, those are going to be rural. So then what we're going to have is we're telling Tableau how to interpret each of these values each of the RUCC values. So it's going to create a new field called population type. And then based on the RUCC value, it's going to assign a population type of metro, micro, or rural. All right, and then when I'm done, then I have to finish this off with the end command. There we go. And go ahead, and right now it says that the calculation is valid, so that means I typed this in correctly. And now I click on apply, and I have a new population type field. Click on OK. If I go to my data sources tab, if I scroll all the way to the right here, we can see the different population types. So RUCC of 2, we know that that's a metro. RUCC value of 6, that should be micro, and it is. So we can see that it calculated it correctly, and we have a population type field populated. Okay, so now we have population type. So that means that we're going to be able to then identify, based on the RUCC value for each of these counties, we can now differentiate these counties so we can not only see them with their percent stroke rates in descending order, but also identify which of these ones are metro, micro, or rural. So we're going to take our population type and we're going to drag that to colors because we're going to color code these. So now what it's doing is it's color coding these based off of our new population type field. But of course, I don't like those default colors. So I'm going to change those. So I'm going to click on colors, edit colors, and null, I want to be gray. Metro, I want to, I've got an error there. Spelled rural twice or differently. I don't like that. So rather than going back for now, I'm just going to keep that in here. And rural, either spelling is going to be a color red, so we can still have them color coded. So now we can see, based off of the color, now we know that with red being rural and orange being micro, we can see, the top sets of highest stroke percentages are from rural and micro areas. It's not until this county in Alabama that's a metropolitan area, that's the first of our high values. But as we scroll through here, we can see the orange and the red predominant. And as we scroll down, we're going to see more and more blue, it looks like. So that kind of indicates where these higher stroke percentages are coming from. All right, so let's see. What we also want to do now with our values here, we want our tooltip to indicate that rural population type. So I'm going to click on tooltip, and then I'm going to append population type, column, comma, and then I'm going to insert the population type value. Click on OK, and now you can see for each of these, I have the indicator of the population type there. All right, we're getting closer to the end, so I'm going to skip ahead some of these filtering and just work on formatting this one right here. So what I want to do is I'm going to go to my population type. I want to be able to add colors here. And there we go. We can see the different colors by the population type, and it used my same color coding. So now we can see the scatter plot. We're showing the metro, micro, and rural for each of these rates. Now they look like there's the rates that the rate of increase based off increased stroke and increased blood pressure, that seems to be pretty much the same regardless of whether it's metro, micro, or rural. We're just seeing at maybe at the lower end that the metro areas seem to have, at least the outliers, or at least the medians, are going to be at a lower median than the rural and micro areas, which seem to be represented at the higher end. So that's another observation that we could make from this visualization. Another thing we can do is we can, there's a way to select this. If I click on metro, now we can only see the metro values. Double click that again, it brings everything back. So what we can do is we can investigate each of these to see what each of those look like, each of the population types. All right, and now what I want to do is I want to do some final formatting here. So percent stroke, we don't like that. That really should be identified as a percentage. Let's worry about our label. So if I double click on that, I bring up this form here, and this is where I can change the x-axis label, and I want to call this stroke rate, and maybe even median stroke rate. Close that, and then do the same thing for my y-axis, and I can call this the median high blood pressure rate, and click on OK. And that's how I can change my X and Y axis labels. And I can also change the heading or my title of this. And let's say I'm going to call this, I want to call this percent of the population diagnosed with a stroke, and the percent of the population reporting high blood pressure. And actually, so if I do that, that's a pretty ugly title. So rather than doing that, let's put that in our tooltip. So I'm going to cancel that, or cancel that. I'm going to copy that. And now if I want to see that in my tooltip instead, I can click on tooltip, and I can actually not just put fields in there, I can put values or words in there like this. So let's take a look at doing that, make that a smaller font, maybe just a 12-point font, and I can even change the color. Let's change the color to red. There we go. Now when I put my value over there, I can see an explanation of the data that I'm looking at, as well as the data values itself. So it's a good idea to put some descriptors in those tooltips, not just the data itself, but explaining what you're looking at in this data set. And then the final step, what I want to do here before we run out of time, is I wanted to make a change to the title of the plot. And I'm looking for my notes on what I wanted to do there. All right, so let's double click on this, and let's just call this stroke rate versus high blood pressure rate. And then I'm going to do a subtitle of median values for each county. And that I want to use as my subtitle. So I'm going to change the font size of that from 15 to 12. And click on OK. The other thing is I don't like off to left. I can double click on this again, and I can make this center the value. So now it's in the center of my plot. There we go. So still some issues here, just running out of time. I would want to change my x-axis label to indicate percentages, and same for my y-axis label. So we can see the relationship between the two. We can see that it's somewhat of a linear relationship. Still want to format, still do some additional formatting. But one final thing I want to take to show you, though, is that we can actually look at this and describe the linear relationship. So if we, so let's say we want to take a look at this, we can go to analysis and go under trend lines. If I want to show a trend line, click on that. Now I can see that it's also showing a trend line for our null values. So let's say I click on that, and that's going to just show me that. But if I want to get rid of that, I can click on null, and now it's going to remove null values well, that didn't work. Sorry. I would have to do something different to filter out the data. So let's just ignore the null values. But if we take a look at these trend lines, we can see that there's a different trend line for each population type. So here's my trend line for my rural, micro, and metro populations. So if I take a look at, put my cursor over each of these trend lines, I can see the linear equation, because we're looking at this as a linear relationship. So it's my y equals mx plus b formula. And it also shows us our R squared value and our P value. So we can see the P value shows that this is a pretty good approximation, a pretty good fit. Or excuse me, it has high confidence that this is the results will be accurate. But when we take a look at the R squared value, which is the coefficient of determination, it's really showing us how the prediction fits our model. So we can see that this has an R squared of 0.68. An ideal R square valued is going to be closer to 1 versus a completely random R squared value would be a 0. So this is not a great fit, but it's a decent fit. And that's when we need to ask ourselves, if we're looking at just approximations just to see, what are possible indicators, this might be good enough of a fit. Certainly see that visually, we can see that there's a correlation between the two. And now we can try to quantify it by this linear line. So with that, we can use this visualization to see that for looking at stroke rates across a county, they're somewhat predictable by the rate of high blood pressure. So if you were going to be looking at which counties maybe that we want to work with to reduce high blood pressure, we could go back to our counties, and this would be an indicator of the geographic areas, or we could even go back to the state level and see which states that we would want to work with to reduce high blood pressure, therefore decreasing the rate of strokes. So all this done here in about 50 minutes using Tableau. We have a lot of visualizations that we'd be able to show our interested stakeholders so that they can actually see the relationship. And it's much more meaningful looking at these plots, the bar charts, the geographic representation. That's much more powerful than looking at our 3,194 rows of data. All right, so with that, I'm going to go back to my presentation so that we can ask some questions. Got a couple minutes left. Do you have any questions? And so today's presentation, this was just an introduction to doing data visualization. And so this was pretty basic stuff in Tableau. One thing to note is I believe everything that I did here today, you can also do in Tableau Public. So if you don't have access to Tableau at your work, I would encourage you to go find some data, maybe at kaggle.com or other data sources, and pull that in and create a Tableau public account and give this a shot. It's quite a powerful tool, and it's really cool that you can do that for free. All right. Final call for questions. All right, so with no questions, if you do, you can find me out on LinkedIn and be happy to connect with you. I also have a Twitter account. I use both those social media to announce webinars like this or to post things out there. So feel free to connect with me through either of those, or reach out to me through my email account as well. But thanks for joining us. And we do have another webinar next month. Natalie Disk is going to be presenting on, it's Agile and Waterfall, different methodologies for project management. And that's part of our spring series of our webinars through the Standard School. So I hope you enjoyed today's presentation or today's webinar and got a lot out of it. I really encourage you to go ahead and use that Tableau Public and give this a try to practice what you saw here and be able to use this in your own work. Thanks for coming today. Bye.